We are looking at the tolerance. We are comparing it to the least unit of measure, L.U.M, and we are comparing their definitions, and at the end of the day we shall see whether they are different or they are the same. And when you look at the least unit of measure, we are saying it is the difference between the upper limit or bound and the lower limit. And on the other end, tolerance is the difference between the greatest and the least acceptable measure. Now, a brief illustration of what we are talking about. When we are given a mass like this one in set builder notation, 29.5 less or equal to m less or equal to 30.5. When we look at the least unit of measure, we are saying it's the difference between the upper limit and the lower limit. Now, looking at our set builder notation here, 30.5 is the upper limit, and 29.5 is the lower limit. And based on that definition, our least unit of measure will be given by the upper limit, 30.5, and the lower limit, 29.5, and let's get the difference. So when you get the difference between the upper limit, 30.5, and the lower limit, 29.5, we are getting it as 1. So 1 is the least unit of measure. Now coming to the tolerance. Tolerance also, we are told, is the difference between the greatest acceptable measure, which is 30.5 in our case, and the least acceptable measure, which is 29.5. So, getting the tolerance, we are told it is the difference. So, we have to subtract the least acceptable measure from the greatest acceptable measure. So, basically what we are talking about is 30.5 minus 29.5. And when we do that subtraction, we are getting 1 as our tolerance. So technically, you can see that the least unit of measure and the tolerance are basically the same. The least unit of measure, which is the difference between the upper bound and the lower bound, is 1. And the tolerance, which is the difference between the greatest acceptable measure and the least acceptable measure, is also 1. So we can conclude to say the least unit of measure and the tolerance are the same. And we can use the tolerance or the least unit of measure to get the absolute error. We can use the least unit of measure or the tolerance to get the absolute error. We know that the absolute error is half of the tolerance or the least unit of measure. So we can use this relationship to get the absolute error when we know the tolerance. So since the tolerance is 1, so half of the tolerance will be our absolute error. So half of 1 is basically 0.5. So 0.5 is our absolute error, which we have gotten from the tolerance using that relationship to say the absolute error is half of the tolerance. So once we know the tolerance, it's a matter of dividing by 2, and what would have gotten will be the absolute error. So in our case, since the tolerance or the least unit of measure is 1, therefore the absolute error will be half of 1, which is 0.5. We are also able to get the midpoint when we know the upper limit and the lower limit. We are also able to get the midpoint. So in our case, the midpoint will be gotten by adding the upper limit and the lower limit. And you see, when we add 30.5 and 29.5, we are getting 60, and half of 60 will be the midpoint. So half of 60 is basically 30. So the midpoint for our mass in set builder notation is 30, and the absolute error is 0.5. Now, there is one other way in which the same set builder notation, the same mass represented in set builder notation like this one, there is another way of representing this one where we could say M is equal to 30 plus or minus 0.5. Now, this 30 here is actually the midpoint. It's actually the midpoint of this set builder notation. And 0.5 is our absolute error. So when we see a measure represented like this, then we must know that 30, this number here, this number occupying this space is always the midpoint, and this number coming after plus or minus is basically our absolute error. So what we are saying is that this information is the same as this. We are also able to get the lower and the upper limit from this information. We can get the lower limit by subtracting the absolute error from the midpoint, and we can also get the upper limit by adding the absolute error to the midpoint. So basically that is the connection between the tolerance or the least unit of measure and the absolute error.